OWASP API Top 10 Part 2. In the previous room, we studied the first 5 principles of OWASP API Security. Now this room will briefly discuss the remaining principles and their potential impact and mitigation measures. Learning objectives: identification of security misconfiguration, preventing denial of service against the API, ensuring appropriate logging and monitoring. Learning prerequisite: how website works, HTTP protocols and methods. Principles of security of OWASP Top 10 web vulnerabilities. So connection, you can handle it yourself. Vulnerability. Part 6. Mass assignment. How does it happen? Mass assignment reflects the scenario where client-side data is automatically bound with the server-side objects or class variables. However, hackers exploit the feature by first understanding the application business logic and sending specially crafted data to the server, acquiring administrative access, or inserting tampered data. This functionality is widely exploited in the last frameworks like Laravel, CodeIgniter, etc. Consider a user's profile dashboard where user can update their profile like associated email address, name. The username of the user is all read-only attribute that cannot be changed. However, malicious actor can edit the username and submit the form. If necessary, filtration is not enabled on the server-side model. It will simply insert updated data in the database. Likely impact. The attack may result data tampering and privilege escalation from a regular user to administrator. Practical example: OpenVM will find a Chrome browser and the API tester application are running automatically, which will use for debugging API endpoints. Bob has an assignment to develop sign-up API endpoint. Rule 6: user. It will take a name, username, and password as an input parameter post method. The user table has credit column with a default value of 50. Users will upgrade their membership and have larger credit value. Bob has successfully designed a form and used the mass assignment feature in Laravel to store all incoming data from the client side to database, as shown below. So we need to post user with type content type xform URL and with body and password credit. Let us do it. So we'll change it to post API rule 5 user without anything, add parameter name, text Bob, user name Bob MNT, password 1, 2, 3. Credit 11,000. Let me see the results. Error. What I missed. 6, not 5. Very nice. We have 11,000 credits. What is the problem here? Bob is not doing any filtering on the server side since you using the mass assignment feature. He is also inserting credit value in a database. Malicious actor can update value. The solution to this problem is pretty simple. Bob must ensure necessary filtering on the server side. So we have the secure version of this one, and now we couldn't override the credit, and ensure the default value should be inserted as even if more than 50 is received from the client side as shown below. Before using any framework, one must study how the backend insertion update are carried out in the Laravel framework. Fillable and guarded arrays mitigate the above mentioned scenario. Avoid using functions that bind an input from the client to code variables automatically. Allow list those properties only that need to get updated from the client side. Is it a good practice blindly insert? Nope. Nah. User S insert. Okay. What would be return credit value after performing question 250? Okay. Vulnerability chapter 7, security misconfiguration. How does it happen? Security misconfiguration depicts an implementation of incorrect and poorly configured security controls that put the security of the whole API at stake. Several factors can be result in security misconfiguration, including improper, incomplete default configuration, publicly accessible storage, cloud storage, cross-origin resource sharing course, and error messages displayed with the sensitive data. Intruders can take advantage of the misconfiguration to perform detailed reconnaissance and get unauthorized access to the system. Security misconfiguration are usually detected by vulnerability scanners or auditing tools, and thus can be curtailed at the initial level. API documentation, a list of endpoints, error logs, etc. must not be publicly accessible to ensure safety against security misconfiguration. Typically, companies deploy security controls like web application firewalls, WAFs, which are not configured to block undesired requests and attacks. Likely impact. Security misconfiguration can give intruders complete knowledge of API components. Firstly, it allows intruders to bypass security mechanisms, stack trace, and other detailed errors can provide the malicious actor access to confidential data and essential system details, further aiding the intruder in profiling the system and gaining access. Practical example. Continue to the Chrome browser. The company MHT is facing serious server availability issue. Therefore, they assigned Bob to develop an API endpoint. API rule 7 ping the get method that will share details regarding service health and status. Bob successfully designed the endpoint, however, he forgot to implement any error handling to avoid any information leakage. Let me see what we need to do. So we have API rule 7 ping v, and we don't need any of that. Get method. We have whole path of the vendor Laravel framework source and where the error occurred. According to this one, we have the whole structure, and we can understand that this application based on Windows. Okay, let me see. We need Laravel of P controller collection. Okay, what is the issue here? In case of unsuccessful clone, the server sent a complete stack trace of response containing function name, controller, route information, file path, etc. An attacker can use the information for profiling, preparing specific attack on the environment. The solution is to issue is pretty simple. The solution to the issue is pretty simple. Bob will create an API endpoint, API rule 7 ping s, that will carry out error handling and only share desired information with the user, as shown below. False message and malform. Let us see. Here we go. Pretty nice, pretty nice. Limit access to administrative interface for unauthorized user and disable them for other user. Disable default username and password for public-facing devices, router, web application firewalls, WAF, etc. Disable directory listing and set proper permission for every file and folder. Remove unnecessary pieces of code, snippets, error logs, etc. and turn off debugging while the code is in the production. Is it an excellent approach? Excellent approach to show error logs from the stack trace of name. Try to use 7s at the attached machine. Oh, okay. What response code do we have? 5,500. What is the error ID number? Error ID number. Error ID number is 4001. Okay. Vulnerability Part 8. Injection. How does it happen? Injection attacks are probably among the oldest API web-based attacks and are still being carried out by hackers on a real-world application. Injection flow occurs when user input is not filtered and is directly processed by an API, thus enabling attacker to perform unintended API action without authorization. An injection may come from structure query language SQL, operating system OS, extendable markup language XML, etc. Nowadays, frameworks often offer functionality to protect against this attack through automatic sanitization of data. However, applications built in custom framework like core PHP are still susceptible to such attacks. Likely impact. Injection flow may lead to information disclosure, data loss, DOS, and complete account over takeover, DOS. This successful injection attack may also cause the intruder to access the sensitive data and even create new functionality and perform remote code execution, RCE. Practical example, so we are going to run some code. A few users of the company MHD reported that their account password has changed and they could not further log in to their original account. Consequently, the dev team found that Bob had developed vulnerable login API endpoint. So now it is API rule 8. We have user in here and log in. Let me see what we have. Get or post? Nope. Get. No get in here. Post. Okay. Incorrect. Let me wipe this one. Password and false. Incorrect. Okay. Oh, we have to run on password SQL injection. So password will change to asterisk or 1 equal 1 dash dash, and we have auth key. Okay, auth key. What can auth key grant us? So now, Bob immediately, the malicious attacker requires the user of the target and password. They can use payload and get authorization key for any account as below. Authorization key for any account. Okay. Authorization. Let me check this one and see if they real. I don't know. But word something. I don't think so. Authorization. Okay. So Bob immediately realized the mistake. He updated the API endpoint. So now we have login S, and we can try it another incorrect password, and use parameterized query and build in filters of the Laravel to sanitize user input. As a result, all malicious payloads were effectively mitigated as shown below. Yep. Ensure to use a well-known library for client-side input validation. If a framework is not used, all client-provided data must be validated first and then filtered and sanitized. Add necessary security rules to the web application firewall WAF. Most of the time, injection flow can be mitigated at the network level. Make use of built-in filters in frameworks like Laravel, CodeIgniter, etc. to validate and filter data. Can injection attacks be carried out? Extra data from. Yeah. Can injection attacks result in remote code? Of course. What is the invalid password? 4 or 3. Okay. So now we have almost lost one. Chapter 9. Improper access manager. How does it happen? Inappropriate asset management refers to scenario where we have two versions of API available on our system. Let's name the API v1 and API v2. Everything is wholly switched to API 2, but previous version API 1 has not been deleted yet. Considering this, one may easily get that the older version of API is API 1, does not have the updated and latest security features, plenty of the obsolete features of API. Version 1 make it possible to find vulnerability scenario, which may lead to data leakage and server takeover via shared database among API versions. It is essentially a but not properly track API endpoints. The potential reason could be incomplete API documentation or absence of compliance with a software development life cycle. As the OCC. A properly maintained, up-to-date API inventory and proper documentation are more crucial than hardware-based security controls for an organization. Likely impact. The older or unpatched API version can allow the intruder to get unauthorized access to confidential data or even complete control of the system. Practical example, we continue with the Chrome browser. During API development, the company MHT has developed different API versions like v1 and v2. The company issued to use latest version API call but forgot to remove the oldest from the server. Consequently, it was found that old API calls like API rule 9, v1 user login return more information like balance, address, etc. against the user as shown below. We don't see the balance or country. Let me repair this one, fix this one, so we don't have post user login. Rule 9 version 1 user login. We have Alice and we have I don't know, Alice email. Nope. Okay. Let me change to what we see in hash. Let me see. Oh, we have balance 100 and country USA. But being the developer of the endpoint realized he must immediately deactivate old and unused assets so the users can only access limited and desired information from the new endpoint. Let me change it to 2 as shown below. And we have only ID and username. Access to the previously developed, sensitive and deprecated API calls must be blocked. At the network level, APIs developed for R&D, QA, production, etc. must be segregated and hosted on the separate servers. Ensure documentation of all API aspects, including authentication, redirects, error codes, policy, and rate limit. Adopt open standard to generate documentation automatically. It is good practice to host all API on the server. Make call Alice password I've just made. What balance 100 and what USA. That's it. Chapter 10. Insufficient login and monitoring. How does it happen? Insufficient login and monitoring reflects a scenario when an attacker conducts malicious activity on the server. However, when you try to track the hacker, there is not enough evidence available due to absence of logging and monitoring mechanisms. Several organizations only focus on infrastructure logging, like network event or server logging, but lack of API logging and monitoring information like the visitor's API, address, endpoint access, input data, etc., along with the timestamp, enable the notification of the threat attack patterns. If login mechanisms are not in place, it would be challenging to identify the attacker and their detail. Nowadays, the latest web frameworks can automatically log requests different level like error, debug information, etc. These errors can be logged in the database or file or even passed to the SIEM solution for detailed analysis. Likely impact: inability to identify attacker or hacker behind the attack. Practical example: continue to use Chrome browser. In the past, the company MHT has been susceptible to multiple attacks, and the exact culprit behind the attacks could not be identified. Therefore, Ball was assigned to make an API endpoint Rule 10 logging get method that will log user metadata, API address, browser version, etc. and save it in the database as well as shown below. Logging. So 10 login. It's not a post, it's a get. Login hi. Boom, boom, boom. And he had this one. Later, it was also decided that same would be forwarded to SIM solution. Security information event management system that is used to aggregate security information in the forms of log, alert, artifacts, and event in a centralized platform that would allow security analysts to perform near real-time analysis during security monitoring. Solution for correlation and analysis. Mitigation measures. Ensure use of the security information and event management system for log management. Keep track of all denied access, failed authentication attempts, and input validation errors using a format imported by SIM and enough detail to identify the intruder. Handle logs as sensitive data and ensure their integrity at rest and in transit. Moreover, implement custom alert to detect suspicious activity as well. Should the API logs be publicly accessible? Nah. So that the attacker must know they are being logged. What is HTTP response code in the case of successful logging and user information? 200. So, in conclusion, that was as simple, it would be correct to say that half of OWASP API Security top 10 list is relevant to authorization and authentication. Most likely API systems are hacked because the failure of authorization or authentication mechanism and security can miss configurations. In a nutshell, API developers must safeguard API in line with best cybersecurity practices. The modules like sign-in, role-based access, user profile settings, etc. must be given more importance, as malicious actors tend to target known endpoints for gaining access to the system. Stay tuned and keep developing secure APIs. I'm done. See you so long.